Okay, first step. First step, you do free body diagrams. And you know what? I'm going to erase this. So this is 5 kilograms. Just erase this so we have room to do the free body diagrams right here. So 5 kilogram, 10 kilogram. All right, let's erase the rope too, just so we can get the forces on these masses. So the rope is there, but we'll just erase it. All right, so what are the forces? Let's call this guy over here. This is going to be M1. This guy's M2. What are the forces on M1? We have the rope is pulling to the right, so we have tension to the right. Gravity always acts down, so that's going to be M1G. Don't say MG because you got two M's. You got M1 and M2. So that's M1G. And then is this object on a surface?
Yes.
Yes. So there's a normal force. Fn for normal force. Not to be confused with net force. Fn here is normal force. Okay, what are the forces acting on M2? Well, which way is the rope acting? Tension is up. Tension is up. And then M2G down. No normal force for M2 because it's not on a surface. Okay? So M1 is equal to 5 kilograms. M2 is equal to 10 kilograms. All right, let's do our sign conventions. So sign conventions are super important. They have to be consistent. So which way is M1 going to accelerate?
Right.
To the right. So let's say that to the right is plus, to the left is minus. Now, what's going to happen to our sign convention? It's going to go doot, 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 doot around the pulley. So over here for M2, down is plus, up is minus. Okay? And then for the vertical, look, for M1, up is plus, down is minus, like that. Now look, kids get confused by that, like, what? So look, with my super cool sketch pad, I can do this. Here's what you're going to think about. So I'm going to grab this sign convention and we're going to move this around. So it goes like this. See if I can do this. So we're going to go boom. Oops. I can rotate it. So look, this goes like this. Now what happens when we get to the pulley? When we get to the pulley, what happens to our sign convention? It goes around the pulley. Boom. You like that, don't you?
Yes,
now look,
I do.
See that right there? So down is what? Plus, because kids get confused, and maybe I shouldn't mention it because maybe you weren't confused, but I just know that kids get confused. They're like, wait a minute, Spaldo, I thought you said that, down is plus. See over here, we're saying that down is positive. But basically, think about it like this: the sign convention. The whole sign convention just rotates around the pulley, so you end up having down as plus over here. Okay? All right. Now, here we go. So we did free body diagrams. Now we're going to sum the forces. So we're going to go M1, M2. So summing forces for M1, we're going to do it X and Y, because we have X and Y for M1, right? What's the only force in the X direction for M1? Tension. That's it. The only X force for M1 is tension. So that's it. T. So that's the sum of the forces. What is it equal to? MA. But don't just say MA.
M1A.
M1A. Tension equals M1A for object 1. All right. In the Y direction, we have normal force up, and then M1G down.
Actually, there's it's tension, no normal force.
No. So look at we're looking at M1 still.
Oh.
Looking at M1. So we have in the Y direction. So this is the Y direction right here. What are the forces in the Y direction? Normal force up, M1G down. Right? So it's going to be tension minus, I'm sorry, not tension, normal force minus M1G. Sum of the forces equals MA, that's M1A. But now look, guys, is M1 accelerating that way?
No.
No. So what does that tell us about the two Y forces? They must be equal. They're canceling each other, right? So there's no acceleration in the Y, but there is an acceleration in the X. Everybody got that? Mm-hmm. This mass right here, M1, accelerates this way, but not that way. So which A can we cross out? The X,
Y.
the X or the Y?
Y.
The Y. So let's just set it equal to 0. Clean this up. There is no acceleration for M1. There is no acceleration in the Y. Okay, so any questions? That's 0. So now, let's go to M2. So for M2, we're going to sum forces, and we don't even have to say X or Y, because there's only one direction. Now look, should we call this the X direction or the Y direction?
Y.
Well, remember, what happened to our X, if you do an XY axis like this, XY, what happens when you go around the pulley? It rotates. You take this XY like this, ready, you go do, XY, 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 you hit the pulley, and then what happens? It wraps around the pulley. I would say that this is the X direction, as weird as that sounds. You know what I'm saying? It's like the X-axis wraps around the pulley. Okay? You smell me?
Yes, I do.
Okay. All right. Now, so for M2, oh, I made this too messy. Let's see. Okay, there we go. For M2, what we have is M2G down, right? But down is plus. Down is plus. Minus T equals M2A. Ba-bam. The hard part's done. The rest of this is algebra. So if you did this correctly, if you do free body diagram, if your summing of forces looks like that, the only thing left to do is algebra, which is not too difficult. Okay, so now let's go through the questions. A, what's the normal force on the 5 kilogram mass? So you're going to take this equation here, solve that equation for normal force. Normal force equals M1G, 5 kilograms, times 9.8. So the normal force comes out as 49 newtons.
Yes. Ba-bam.
Good job.
Ba-bam.
Ba-bam.
Why say good job, Mr. Spaulding?
Because you did a good job. Okay, part B, the tension in the cable. Now look, these two questions here, part B and part C, are really like the same calculation, because what you're going to do for this next part is you're going to take two equations and substitute them together. Okay, so we clean this up. So what we're going to do now is we're going to take this equation here and this equation here. So look, what do these two equations have in common? Tension and
Tension.
acceleration. If you have two equations and two unknowns, can you solve it?
Yes.
Yeah. I think the easiest way to do this is take this equation, so T equals M1A, take that, plug it in there. So what do you get? You're going to go M2G minus what? M1A equals M2A. The only thing missing in there is what? A. So this is going to be, so get all the A's on one side. You're going to have M1A plus M2A equals M2G. Factor out the A. Oh, I need Michael, my TA. My cell phone's going to ring next. Okay, you guys follow that? Okay, so M2 is 10, so that's going to be 10 kilograms. Gravity's 9.8. We're just plugging in here. And then M1 plus M2, you add the two masses together, you get 15. So then the kilograms cancel, and you get meter per second squared, and the answer is 6.53. So the meter per second squared. So this acceleration comes out as 6.53 meter per second squared. That's the answer to part C. 6.53 meter per second squared. Now, how do we get part B?
The tension.
You could just, to get part B, to plug it into this first equation up here. To find the tension, you could plug into this, or if you wanted a little more algebra, if you're just feeling like you want to do some more algebra, you could plug into this, right? Either one. I think the first one's easier. T equals M1A, so that's going to be 5 kilograms times 6.53, and this gives a tension of 32.7. So the tension in the cable, 32.7, not meter per second squared, newtons. 32.7 is the tension. All right, and then the last question. So if the 10 kilogram mass starts 1 meter above the floor, so can I erase the screen here? So what kind of question is this last one? There's a kinematic. So basically, like, here's the floor down here. There's the floor. And you're told that this height right here is 1 meter. Okay? And then V initial is 0. What else do we know? The acceleration is 6.53. We just found that. So what would be the time for the 10 kilogram mass to reach the floor? So this is kinematic. So to answer this question right here, to answer this guy, you go V, nope, not that one. We don't have V final. Go like this. X equals 1/2 AT squared plus V initial T. V initial is 0. So now you can solve this for time. 2x over A. So that's 2 times, technically it's -1. Why is it -1? Because the mass goes down, but the acceleration, actually, you know what? I take that back, guys. Who can correct me? I take it back. What did we say about down? Down is positive, Spaldo. That's why our acceleration is positive, right? The acceleration is positive because we said down was positive. Spaldo. What a loser. I'm just kidding, Spaldo. You're not a loser. Okay. Okay, so 2 times 1, and then acceleration is 6.53. Plug that in. The time is 0.55 seconds. 0.553 seconds. Okay, and then last question. The velocity of the mass when it hits the ground. So let's do that down here. There's different ways you could do it. Yo.
Wait, so when you did the square root of 2, how do you get 1 meter?
Because that's how far the mass falls. It says right here, the mass starts 1 meter above the floor. So that's the displacement. 1 meter is how far it falls, which is the x. Okay, so now, hey, to do this question, there's multiple ways you could do it. I went like this. Vf squared equals V initial squared plus 2ax. V initial is 0. So V final is going to be square root 2ax. So 2 times 6.53 times 1. And then this gives a final velocity of 3.6.